Okay, I'm John McDonald. Whoa, we've already moved forward. And I'm talking about HPCI, which is a new module on CPAN for high performance computing. And I'll give a bit of an introduction, go over components, how you use it, status, future. So when you write large programs, they tend to run on many computers, and there's a lot of different ways of doing it. There's clusters, clouds, multiprocessors, and for HPCI, I call them all a cluster, just because that's what I started with. The only reason a program that wants to run on many computers worries too much about the cluster is to get the job done. I want to run all of these jobs and distribute them, please. Each cluster type, though, has its own interface software. They're all different. So if you write your program to run on one, you can't move it to a different kind of distributed system very easily. Now, clusters are defined more than anything just by that interface software. Under the hood, they're usually Linux or sometimes BSD or sometimes other things, but to a large extent, you just call the interface and do things. So what HPCI is set up to do is to provide an abstract interface that you can use for any kind of cluster. You write your program once to act on on the HPCI cluster. And one of the parameters is, what kind of cluster do I really want to use this time? But you can change the parameter to go on a different kind of cluster. Now you can edit the program text, or you can make it a command line parameter or whatever. Now, moving to a different cluster, well, if you're in a big organization, you've got a cluster and it's broken, and you can't wait until it gets fixed, you might want to run your program somewhere else. If it's a research environment where you're trying to duplicate somebody else's results, your lab might have a different kind of clustering system than theirs. There's lots of reasons for it. Now, underneath HPCI, there's HPCD, high performance computing drivers. If anybody's used DBI, DBD, the resemblance in name is not accidental. It's the same general idea. So the driver translates the abstract HPCI interface into the specific one for that particular kind of cluster. And for every kind of cluster you want to use, you need a separate driver. So the general components of the abstract interface, I'm going to go through each of these in turn. The top level thing is a group. That you create the group, telling it what kind of cluster it's running on. It manages the whole process of setting up things to be run remotely, any dependencies where these steps have to go before these ones, that sort of thing. So that there's the scheduling in terms of those dependencies, detecting when individual things run, deciding whether something can be run again because it failed in a way that can be corrected, collecting status, and so on. A stage is a computation to be run on a remote computer. So it's the entire computation that goes to one remote computer. And so it needs a command to be run. There's lots of wrapping stuff. We'll get into that more later. A run is usually the same as a stage, but if you get retries, there could be more than one run for a stage. So there's a logger. If you pass one to HPCI, it'll use it. Otherwise, it'll create its own. And this is logging everything in the top level system. It's not all the remote jobs themselves. It's just creating and getting status back and retries from those jobs. unless you provide your own logger and have the code in the remote jobs connect to it yourself, it's not one log for the whole thing. Resource requirements. Now, most kinds of clusters have part of their interface being something that says, this job needs this much memory, it runs for this length of time, and it uses that to schedule things, to decide which systems it runs on, that sort of stuff. The naming and just the resources that you have to specify, that you can specify, is going to be cluster specific. There's a bit of translation of naming done by HPCI, so we have standard names for some things. With a resource failing, there's two kinds. A soft failure, it'll send a signal to the job warning it that it's gone over the soft limit. A hard failure, it gets killed. Not all clusters will support either or both of those. When you send a job off to another computer, there's often environmental things that you want to wrap around it. So both the command line environment, search paths, possibly files to pass on, and all sorts of things like that. The directory layout that HPCI provides by default, it can be overwritten in many ways. You'll see some of that a bit later. But there's a top-level directory that probably exists, spaced here. Immediately under it, the group directory gets created with the group name and a timestamp. Inside there, the log for the job, and separate directories for each stage, which get the name of the stage. Within a stage directory, there's the script, and a separate directory for each run, and a symlink that points back to the last run, because usually that's the one you care about. If there were retries, the one that happened last either failed in a way that couldn't be retried, or it succeeded, so that's the one you're looking at. Within a run directory, you get std out and std. So, dynamics of using it. Create a group, and you have to tell it what kind of cluster it is. The name is optional. There's a bunch of parameters. Now there's a bit of social engineering here. The default name is default group name, which is big and clunky. It encourages people to choose a name. But if you've got a small scale kind of job where you're not running huge numbers of different HPCI process collections, then having a default name is easy enough. Max concurrent is managed by HPCI itself. It limits the number of stages that are, or runs that are executing at the same time. There are often similar sorts of things within the cluster interface, the cluster interface software, so you don't necessarily need it. You can set the base directory or group directory. You can set logging parameters, environment parameters. Logging parameters, either you can provide a log, or you can say, control where the log is put, either a full path or override the default directory or path file name. Okay, create an object. Now you have to have a name, and you have to have a command. We've got a couple of convenience methods for creating commands, so you don't necessarily have to have it as part of the actual creation, but it has to be done fairly soon thereafter. These set commands, they translate things like take a list value and turn it into -- list A, -- list B, -- list C. But for something like Python, it knows that it's -- list A, B, C, and it adds in the interpreter name. You can set the directory explicitly if you don't want the default. Resources required is a hash, which is often going to be specific to the type of cluster. Retry resources required. If the driver is capable of detecting that a resource was exceeded, then if you provide retry resources required, it's a list of alternate values to use. It just takes the next one that's bigger than the last one for a retry. That's only supported right now for memory size. Failure action, if a stage fails, do you stop running any stages that depend on it, stop running anything else, or ignore it? This is a job that always gives a bad status even though it succeeded. And environment passing. You can copy things out of the environment. It can be done either in the group or in the stage. And I think I've got the list, yeah. You can select which ones to retain or select which ones to remove. Usually you'll do one or the other, although if you use a pattern, then you might combine them. You can have a list, an additional set that you add explicitly. And whatever you end up with, if there was anything, then it'll get put into the script that gets run. If nothing was provided anywhere, then there's nothing put into the script. Dependencies, we've got prerequisites, dependents. Those are two sides of an arrow. A prerequisite has to run first, the dependent has to run later. Often you'll have a few stages that are building files that get used by a whole bunch of others. So preparation things, a whole bunch of processing things. Maybe you'll have a group of report steps afterwards. And the add deps can be specified as 1-to-1, 1-to-many, many-to-one, many-to-many. You just give a list, and you actually use the stage name rather than the object references. Normally you don't even bother keeping the stage object references. And then the final thing is execute. And that's a single atomic thing. All of this, it will not finish until all of the stages that are going to be run have completed, and returns a structure that has the status. And the status is a hash by stage name, and for each one of them there's an array by run number, and then there's a hash at the bottom. The bottom level hash always has exit status, and it can have anything else that the specific cluster reports on. The current status, there's HPCI itself and HPCD SGE are available in CPAN. SGE, which is Sun Grid Engine, is the kind of cluster we have in my lab, so that's the one we developed first. We've been running it for 6 months now in various incarnations. There's also a driver called HPCD Uni that's part of HPCI, and it just does a fork for creating a stage, runs it on the same system. That's important for testing. When you download something, you might not be on one of the systems in your lab that has access to the cluster or whatever. Or you might require authorization, that sort of thing, and it hasn't been set up for that on the base tests. The other thing you can use with Uni is just a fallback. You know, the cluster's broken and you don't have a second kind, run it with Uni, and so it takes a long time on your system, but at least it's operating as opposed to not doing. SGE, as I say, has been pretty well tested at our lab. However, I got a couple of co-op students writing tests about 2 weeks ago, and they're coming up with all sorts of things. So I'm going to have a new release shortly that covers the ones they've found. Now, the future. Main thing I need at the moment is a community. As I say, we've got one kind of cluster in our lab. I don't have access to others to build drivers for it. So to make this maximally useful, I need drivers for all kinds of clusters. I'm actually going to be getting access to a couple of other kinds, which my boss says he's going to arrange, and I haven't figured out what they are or when. So I'd like to help people if they want to write drivers for clusters that I don't have access to, or additions to HPCI itself. As new drivers come along, there's probably holes in the top level definition that need to be covered. I know of a couple that I'm planning to put in already. Clouds as opposed to clusters. At the moment, everything assumes that you've got a shared file system, and so when you run your job, it just goes to the same directory and runs this job that was already created, and its output files are available to whatever stages later on need them. With clouds, there's probably going to be bundling of files that have to go along with a stage, results that come back. There's probably going to be extra parameters for authorization and maybe even choosing subsets of nodes and things like that. And we've got some resources. I've got a mailing list set up, and bug reports can go through either the RT system on CPAN or directly to Boutros Lab software. And if anybody needs to talk to me, that's my mail address. I also get all the Boutros Lab software. And so, any questions? Yes. Well, if just fork and exec running a job is going to spread things across the different cores, I think that actually works fairly well. So that's where I put in the max concurrent. So that's the top level thing that HPCI manages. It's not the driver itself. Can't read that, but okay. Time's up, so anybody has further questions, come see me. And thank you very much.